Okay, Algebra 2, let's go ahead and add, subtract, and multiply. Let's put and multiply polynomials. So a whole bunch of this you've been doing before. So you've added polynomials lots of times. We're just going to start with your example 1 here. And some key things to remember about adding polynomials is that you only want to add your like terms. So plus, oopsies, sorry about that, negative 2x squared minus 3x plus 2. Okay, so when you're adding polynomials, it's pretty straightforward. We don't actually need those parentheses there. So we're just going to add up our like terms here. So 3x squared, negative 2x squared for a positive x squared. Then we have a 4x and a negative 3x for a positive x, because 4 minus 3. And then our last one here is a 1 plus 2, positive 3. So it's as simple as that. Just some key things, right? So only combine like terms. You can of course scratch out as you go, and I'm also just going to say watch out for negatives, right? Just be careful of those. Watch out for those negatives. All right, then we're going to move on to subtracting. And again, you've done this before, so I'm not going to take a lot of time on it. Subtracting, that's not how you spell it. Subtracting, there we go. Subtracting polynomials. So for your example 2, we're going to do 7x to the 4th minus 9x cubed minus 4x squared, all minus 2x to the 4th plus 3x cubed, and minus x squared. Okay, so what I recommend, even though we're algebra 2, even though we know that we're subtracting, it's always just a good idea to break down those parentheses, 4x squared, and distribute this negative. So distribute negative. Always a good idea. Sorry, I think I need a little bit more coffee this morning to get everything. So negative 2x to the 4th, negative 3x cubed, and now this is a positive x squared, just because those negatives can get a little tricky in there. So now we can look at some like terms. So we have 7x to the 4th minus 2x to the 4th, so 5x to the 4th, and then we have negative 9x cubed and a negative 3x cubed, so minus 12x cubed. And then this last one here is we have negative x to the 4th, but now we have a positive x squared, so we get a negative 3x squared once we combine everything there. So that's our adding and subtracting. Pretty straightforward. And then we of course are also going to multiply. So multiply. And we're going to start with just a monomial, so one term, 7x to the 3rd, times a trinomial, 5x squared, plus 3x plus 1. So as a reminder here, you of course can distribute, and when you're multiplying, you add exponents, right? You add the exponents as long as they're the same variable. So 7x cubed times 5x squared is going to get us 35x to the 5th, because 3 plus 2. And then you just keep going. You can keep distributing this all the way out. So plus 21x to the fourth, and then plus 7x cubed. So as always, you can distribute if you want to. Sorry, that was example 3 there. I didn't label that. Once again, probably need some more coffee. We're getting there this morning. But now we're gonna multiply. So example 4, using the box method, which some of you love. I know you love box method. And the reason that we're going to use this box method is because when we divide tomorrow, it will come in really helpful. And also the box method is, for those of you that have not used it, it's pretty neat on your paper. It doesn't take up a lot of space. Okay, so normally you, of course, if you wanted to, right, you could distribute every term. So multiply, keep going, example. That takes a while and it ends up being really long. So what we're going to do is that we're going to end up setting up a box here. And you're going to put one of your polynomials going down. So I'm going to take this polynomial right here, and I'm going to write the terms going down. So we're going to do 3x squared plus x minus 2. And if you notice, I took the coefficients with it too. So I'm just going to highlight that so you all see where that's coming from. All right, now we're going to take this other one, so this 4x squared minus 2x minus 1, and we're going to put it on the top. So negative 4x squared minus 2x and minus 1. I just need to bring this box over a little bit more. There we go. Okay, so you, of course, if you wanted to, you could write some grid lines here to keep all your work nice and neat. I'm just going to write it as is, and we're going to multiply both these terms across. So I have this new pointer. We're going to take this 3x squared and this negative 4x squared, and we're going to multiply them together. So that's going to a positive 3 times a negative 4 is a negative 12. There we go. I promise I'm with you this morning. Negative 12x to the fourth. Okay, and then I like to work down. It's up to you which direction you want to go. So once again, I'm going to take this x plus x times negative 4x squared, so negative 4x to the third, and again working down. So now I have a positive 8x squared. All right, now we start that over again. So now we're going to do 3x squared and this negative 2x. All right, so now we have a negative 6x cubed, and working down, negative 2x squared, and a positive 4x. Last line, so this is just a negative 1, so it's negative 3x squared, negative x, and a positive 2. All right, and what's so nice about this box method, for the most part, there's a few exceptions here, is that all your like terms are in a diagonal. So we have those, we have our x squareds, and then lastly, with purple, we have our x's, and we can just go ahead and combine all of our like terms. So final answer here, I'll write it over on the left-hand side, is negative 12x to the fourth. Then we have negative 4x cubed and negative 6x cubed, so negative 10x cubed. 8x squared, negative 2x squared, negative 3x squared is a negative 3x squared. And then we have a positive 3x squared. There we go, positive 3x squared. And 4x and a negative x is going to get you a positive 3x, and then a positive 2. And that's your final answer right there. So it definitely is a lot of work when you're multiplying these polynomials together, but if you want to use that box there to help you out, it kind of keeps your work nice and neat. Okay, so last thing, and this is just kind of like a cool, neat thing. All right, this part's pretty neat. We are going to expand binomials using Pascal's triangle. and maybe you read a little bit about this, but this is pretty fun. Side note, Miss Reed's cat is named Pascal, so whenever you tell her that you know, or whenever you see her, tell her that you know her cat, Pascal. So let's start with a triangle. So Pascal's triangle is formed by starting off with 1, and then you take the numbers on either side, so 0 and 0, because there's nothing there, and you add them together to get your next row. So 0 plus 1 is 1, 0 plus 1 is 1. Okay, now we're going to add these two numbers. So 1 plus 1 is 2, but then of course, 2, but then of course 1 plus 0 is still 1, 1 plus 0 is still 1. And this pattern continues. 1 plus 2 is 3. Keep moving this paper. 2 plus 1 is 3, but don't forget about the side ones. 1 plus 0 and 1 plus 0. All right, now let's start over on the side. So 1 plus 0, 1 plus 3, 3 plus 3, 3 plus 1, and 1 plus 0. And we'll do a few more rows here. So 1, 5, 10, 10, 5, and 1. All right. And for our expanding binomials purpose, of course, this could continue and continue, but this is where we're going to stop. So we actually go ahead and we call this row 0. And then we have row 1, 2, 3, 4, and 5. And the reason is that we go up to that 5th row is that these are our exponents, right? So when we're expanding binomials, that is the power to which we're expanding them. And the reason that we do it that way is that if you'll see here, so we have a plus b to the power of 0, well, that's just going to give us 1. A plus b to the power of 0. And this is now our coefficient of 1. It's a constant in this term, but as we go on, they become our coefficients. So now we have a plus b to the power of 1. Well, that, of course, is just a plus b. And as you can see here, this would be 1a and 1b. All right, so let's continue this pattern, see how it works out for us. So now we have a plus b to the power of 2. Okay, so I want you to be a little bit careful of your exponents here. Watch what we do. So we have 1a squared. So we're starting off with that a squared plus 2ab. So the a went down by 1 exponent, the b went up by 1 exponent, plus 1b squared. All right, now again, the a went down and the b went up in exponents. So this happens again with ab cubed. So our coefficients are going to be 1, 3, 3, and 1. So we have 1a cubed. All right, now we're going to take, okay, plus 3. Take 1 away from the a, so a squared, but add a b. Plus 3, again, take away 1ab squared. So we took away 1 from the a, added an exponent to the b. And then lastly, plus 1b cubed. All right, and this pattern keeps continuing. So a plus b to the 4th, 1a to the 4th, plus 4 a cubed b plus 6 a squared b squared plus 4 a b cubed plus 1b to the 4th. All right, I got distracted by my low battery. I have to plug it in. All right, and our very last one, a plus b to the 5th. Let's hope I have enough room to write this on here. So we have 1a to the 5th plus 5 a to the 4th b plus 10 a cubed b squared plus 10 again a squared b cubed. I'm taking away 1 from a every single time, adding an exponent to b, plus 5 a b to the 4th. I'm so close. Plus 5 plus b to the 5th. Almost in there. Got it in. Okay, so that's expanding our binomials. And the whole reason that we do that, and the whole reason that we go through that pattern, is for an example like this. So example, I think I'm on 4, but don't, actually I think I'm on 5. Example 5. Could be wrong on that one, but somewhere in there. All right, and we have x minus 3 to the 4th. Okay, so I know that I'm going to go ahead and we are going to use these coefficients right here. So 1, 4, 6, 4, and 1. All right, so when we expand this, we're going to go ahead and also we need to define, we know A is going to be x, but we know B is going to be negative 3. So we just have to be a little bit careful with our negatives here when we're expanding them. So we're going to have 1 x to the 4th, all right, and then plus, our next one is 4 for those coefficients, and we're going to, remember, we're going to take x to the 3rd, because we're subtracting 1, but times b, which is negative 3, all right, plus 6, and we now have x squared times b, negative 3 to the power of 2, all right, plus 4, and now we're down to just x to the power of 1, so just x times b, which is negative 3 to the power of 3, plus 1 times negative 3 to the power of 4. All right, so obviously we don't leave it like this. We put everything together. So we have x to the 4th, all right, now we have 4x to the 3rd times negative 3, so negative 12x to the 3rd, all right. We have a 6 times a negative 3 times a negative 3, that's going to be a positive, so this is going to give us positive 9 times 6, so plus 54x squared. All right, now we have a negative 3 times a negative 3 times a negative 3, that's negative 27 times 4, it's a negative 108x, and then this one is a negative 3rd to the power of 4, that's going to be a positive 81. And now we just expanded it pretty easily without having to go through and multiply x minus 3 4 times together. So let's just try one more here. Actually, let's pick a different color. This is light blue. So we have example 6 here, and we're going to do 2y plus 4 to the power of 3. And I always like to say what my a is. So my a is 2y, and my b is 4, just to remind myself as to when I'm expanding what's going on here. And again, we're saying x to the 3rd, so we're going to use these coefficients of 1, 3, 3, 1. All right, so we have 1 times 2y to the power of 3 plus 3 for my coefficient, and then we have a, so 2y squared plus, times 4. Got that b in there, times 4. All right, plus 3 again. And now we have 2y, but we have 4 to the power of 2. And then plus that b cubed, so plus 4 cubed on this last one. And now we're going to put everything together. So 2y to the power of 3 is 8y cubed. All right, plus, okay, we have 2y times 2y, so that's going to be the y squared, 4y squared times 3 times 4. So we now have a 24y squared. All right. And we have 3 times 2, that's 6 times 16 for the 4 squared. So that's going to give us a 96y. And then that last one times 4 cubed is 64. And just like that, we expanded that binomial, 8y cubed plus 24y squared plus 96y plus 64. And that's expanding our binomials using Pascal's triangle.